Hello everyone, this is the first of a series of videos dedicated to water chemistry. We are going to be looking at the main characteristics of global water resources. What type of water do we have available in Earth and where it is. We're going to be looking at physicochemical factors that are important when monitoring water, both fresh water and seawater. And specifically, we will be looking at salinity and at something called residence times. And we will also be looking at the chemical and physical properties of water, and specifically three processes that water is involved and that are fundamental in an environmental context: the process of hydration, the process of complexation, and the process of chelation. The video is separated in several parts to hopefully make the content easier to follow. In this first video, I'm going to be looking at the main characteristics of global water resources. There is a lot of water in Earth. Around 73% of Earth's surface is covered by water. However, of that amount, most of it is salty water. Only of that 73% of water, around 96% is oceans, seas, salty water, and only a small amount, around 2.5, is fresh water. Of that fresh water, most of it is trapped in impermanent ice or ice caps or glaciers. And around 30% is groundwater. Only around 1% is what we call surface water, either snow, ice, or but not permanent snow and ice, or lakes, rivers, etc. Of that 1.3%, most of it is more or less trapped in ice and snow. Around 73% is non-permanent ice and snow cover. Around 20% is in lakes, and then you have small amounts of atmospheric water, biological water, water in plants, rivers, a tiny percentage, swamps and marshes, and also moist water in the soil moisture. This table is another way of presenting the information in the previous graph, and you can see here the 96% of water which is in oceans and seas. Of the total fresh water, how most of it is in glaciers and permanent snow cover, and quite a large proportion also in groundwater, and then how in general surface waters make up less than 1%, rivers and lakes, what we typically associate with freshwater resources, are less than 1% of total freshwater resources. Ocean water is salty. 3.5% dissolved solids, 3.5% of salts. That means in 100 grams of water, 3.5 grams will be salts, and the rest water. If you think of 1 kilo of seawater, around 35 grams of that kilo will be assorted ions, salts, and the rest, 965 grams, give or take, will be water, H2O. Of those 35 grams, most of it is in the form of chloride anions and sodium ions, and that is because the main salt dissolving in ocean water is sodium chloride. But it will not be as compound sodium chloride, it will be as the ions, the sodium ion and the chloride anion. And there are also other minor components. You have sulfates, carbonates, magnesium, calcium, etc. Typically, salinity is measured in something called parts per thousand, and it has this symbol. Typical salinity or average salinity for Earth is 35 parts per thousand. but salinity is variable. Some oceans, some seas will be more salty than others. So we consider a water body to be hyposaline when the salinity is less than 33 parts per thousand, and hypersaline when it's more than 38 parts per thousand. So I would like you to stop the video now and have a think at these two questions that I'm posing here. What factors influence the salinity of a water body? Imagine an ocean or a sea. What factors would make that ocean be more or less salty than another? What factors can make salinity increase or decrease? So stop the video now. So hopefully you stop the video and have a look at, have a think at these two questions. What factors influence salinity, and what can make salinity in a water body increase or decrease? And the answer is water, and specifically adding or removing water. So salinity decreases by precipitation, so the presence of rain or snow, and river runoff. And melting snow. In salinity will increase when there is evaporation, for example, at high temperatures, or by the formation of sea ice, because then you are removing water, which becomes it becomes a layer in the surface, and the water underneath will be more salty. This is one way of showing what we call the hydrological cycle or the water cycle. Then it tries to show how the total water resources on Earth and how it is distributed and how water moves from one part of the cycle to another. So you have a certain amount of water in the atmosphere, and then that water is removed from the atmosphere by the process of precipitation. And precipitation can happen in a water body, in a river or a sea or a lake, or inland. How can a water body lose water? Well, by the process of evaporation. If you're inland, you have two processes that can remove water from the land and putting it back into the atmosphere, and that is evaporation, as in the previous case, and also transpiration, in which plants are involved. You also have runoff, by rivers and just runoff of water from land to sea, and you also have a certain amount of water that seeps into the groundwater. So you have a total amount of water on Earth, and it moves across the atmosphere, land, and water bodies, and we will look into this water cycle later in this session. This is a slide that shows how the size of a water body and its salinity, and it presents here on the x-axis, you have the area of your water body, and here in the y-axis you have the salinity in parts per thousand. So you have very large water bodies in which the salinity is lower, and you have very small water bodies in which you can have very high salinity. And then you have all sorts of values in between. But notice that this curve has an L shape. There are no values in this area of the graph. There are no very large water bodies that are at the same time extremely saline. The reason is probably because if you have a region where you have a water body which is large enough to have been generated, that means that there is sufficient rainfall to produce that water body, and that precludes, if you have sufficient rainfall, that will keep salinity under control. So there isn't a huge lake that is very salty. You can have a very, very small lake, relatively very small water body, which is very salty, or you can have large water bodies, and then you have a lower salinity. but you do not have a very large water body with very high salinity. Salinity varies with latitude, and that is because it's related to the access to the process of accessing water, rainfall, and losing water, the process of evaporation. This graph, in green you have salinity in parts per thousand, and in red you have a curve with temperatures, and here in the y-axis you have latitude. So you've got that salinity is low in the polar regions, and that is because there is a lot of rain and snow. It's also low, relatively low in the equator, and that is because although there is a lot of evaporation because of the temperatures, there's also a lot of rain, and that keeps salinity lower. And salinity peaks in the tropics, in the mid-latitudes, because there is a high rate of evaporation, temperatures are high, and rainfall is less than in the equator, so that increases salinity. So polar region salinity is low. The mid-latitudes, the salinity is higher because the temperature is high, and that means a high rate of evaporation, and there is not that much rainfall, and salinity goes down or it decreases in the equator because yes, the temperature is high, but there is also a lot of rain.